Hi y'all, in this video we'll discuss Euler diagrams. Now I'll point out this word is pronounced Euler. There are four basic types of Euler diagrams we'll be using, and I'll discuss the types of problems we'll use these for as we go through them. But to just look at what these four Euler diagrams are, we see this first one where A is completely inside of B. This is representing the situation all A are B. Again, this is the situation all A are B. All of the A are clearly here within the set B. This situation here is representing the situation where we say that some A are B. This X here tells us this is both an A and B, and clearly demonstrates that some of the A's are B's. This diagram here, the X out here is an A and not in B, and it's going to tell us that some of the A's are not B's. It's not clear whether or not there are some A's that are. This diagram is typically representing that way, but we can't guarantee that the way this is written. That as we can in this version over here. Here, A and B are completely separate. This is going to represent the situation no A are B. We're going to use Euler diagrams to help us solve certain or determine the validity of certain types of arguments, and this will require some care. So let's look at some examples of using Euler diagrams to determine the validity of arguments. In example A, we're told to use an Euler diagram to determine the validity of this argument. A reads, all dinosaurs are cool, all stegosauruses are dinosaurs, therefore all stegosauruses are cool. To use an Euler diagram to help us with this problem, we first need to focus on the premises. Alright? And we need to determine how we can draw a diagram that represents those premises correctly. To help me with this, I'm first going to label this top premise as D, and this bottom one is S, just so as I have a basis to talk about them in my Euler diagram, which I'll put down here at the bottom of the board. All dinosaurs are cool, all stegosauruses are dinosaurs. Putting D here on the board helps me to kind of get a feel for how this should work. All dinosaurs are represented within this circle here in the Euler diagram. Since all stegosaurs are dinosaurs, they must be included in here. Again, all stegosauruses being dinosaurs must be included in this set of dinosaurs. Since all dinosaurs are cool, we'll put that as set C, and all stegosauruses are dinosaurs. It has to follow that for any dinosaur, any stegosaurus I pick, no matter what they are, they're within the set C and are therefore cool. So the conclusion here, all stegosauruses are cool, is indeed valid. Or that is valid. Example B reads, some genetically modified foods are safe. Some organic foods are safe. Therefore, all organic foods are genetically modified. Again, in this example, we want to use an Euler diagram to determine if this argument is valid. Looking at this, I see a relationship among all of these that they're all safe, or at least some of them are safe. So let's label this circle S representing safe. Alright, and I'll put a G for some of the genetically modified foods. Should have been a G. And an O for the organic foods. We know some of them are within safe. And certainly, I could put O here and G here based on that discussion. So from the premises, I could get a diagram like this. Does this necessarily guarantee that all organic foods are genetically modified? Well, nothing in my diagram, nothing in this description describes that that had to have been the case. That is, that these circles must have overlapped. Alright, because nothing guaranteed that in the way this was structured, this argument is not valid. Again, this is not valid. The argument in C reads, some politicians are in jail. All people in jail are guilty. Therefore, all politicians are in jail. As with all of our Euler diagrams, to use this to determine validity, we need to focus on the premises first. Looking at these carefully, I want to start with all people in jail are guilty, and be careful about how I draw that. What this is saying is that if I look at the set of people who are in jail with a marker that actually writes, and I draw them like this, I have all those people in jail. We know all of them are guilty. So I'm going to put guilty out here. Okay. Carefully looking at the statement, all people in jail are guilty, says that if they're in jail, they must be guilty. It doesn't actually imply that there aren't guilty people who are not in jail. Further, we're told here in the parentheses that some politicians are in jail. And in fact, we know that some of the politicians here reside in jail. That's fine. But that doesn't tell us that there aren't guilty politicians who are outside of jail, nor does it tell us that there aren't politicians who are outside of both guilty and jail. So some of them are here, but P really should be big P, the circle involving all of P, could look something like this. And that's kind of the most general way I could draw P. Because of that, I certainly can't guarantee that all politicians are in jail. So this argument is not valid. The argument in example D reads, all hikers carry backpacks. Joey carries a backpack. Therefore, Joey is a hiker. Examining this, again, we're going to start with the parentheses, and I'll start with this first part. All hikers carry backpacks. Well, if I have a circle representing backpacks, all hikers carrying backpacks, well, if you're a hiker, then they should be inside of backpacks. Alright, so the hikers are completely contained within the backpacks. That is, all the hikers carry backpacks. Joey carries a backpack. Now let's consider this. Where does Joey live? Does Joey live out here? No, certainly not. Joey carries a backpack. So Jerry can't be there. Joey can't be there. Does Joey live there, or does Joey live there? Alright. That's our question here. Which is it? Based on these premises, we don't have a good feel for this. So the answer to the question is, does this set of premises lead inextricably to this conclusion that Joey is a hiker? The answer is certainly no. I don't know which place Joey has to live. Alright, which of these circles Joey should be within? Is it just the B, not including the H, or is it the H inside of the B? I don't know. Alright, so the answer to this to whether or not this argument is valid is it is not. The premises didn't lead inextricably to this conclusion, so the argument is not valid. The argument E reads, all rainy days are cloudy. Today is a rainy day. Therefore, today is a cloudy day. Looking at an Euler diagram for this, I should have a circle representing the cloudy days with the rainy days inside of there. Trying to determine where today fits, well, today is a rainy day. Today goes right there. If today is within rainy, which is within cloudy, then today is also a cloudy day. So using this Euler diagram, we see that indeed this is a valid argument. The argument in F reads, all rainy days are cloudy. Today is a cloudy day. Therefore, today is a rainy day. This example is very similar to the example E, but let's be very careful about what it says. Starting with the first premise, we can draw a set of circles representing first cloudy and rainy within cloudy. Then we need to see the relationship of the second premise to the first. Today is a cloudy day. So our goal with this is to determine where that today fits. Is today here, inside just cloudy and not raining, or inside raining, which is also within cloudy? Nothing in these premises allows us to determine which that case is, so we have to say that this is not a valid argument. The last example we'll consider is the argument, some unicorns do not have wings. All things with wings can fly, therefore some unicorns can fly. Breaking this argument down, let's first look at the second premise, all things with wings can fly. What that's going to imply is that we have a circle representing things that can fly, within which there are some things with wings. That is, if it has wings, then it can fly. That's another way to think about what the statement's saying. Now, to determine how to address this statement, some unicorns do not have wings, well, we would want to consider the fact, well, where do the unicorns go? Do they go here or here? And does that statement preclude there being any unicorns here? Now that's an interesting question here. I can't distinguish from that statement, whether unicorns circle should be here or just out here. That's actually hard for me to tell. And in fact, some unicorns do not have wings, doesn't preclude there from being unicorns that do have wings. So I really am unclear on what exactly this is saying. But more to the point, the conclusion that's asked to be drawn here, some unicorns can fly. I cannot guarantee that I've got any unicorns within that flight circle. I can't guarantee that. Because this set of premises does not always lead to this conclusion, I would have to say this argument is not valid. So that was a look at using some Euler diagrams to determine the validity of certain types of arguments. Have fun with logic.